Okay, in that first video we saw how to solve simultaneous equations graphically. We would plot them on our coordinate system and we would look at the point where they both cross over. But we are more likely to be asked to solve simultaneous equations algebraically. And how we do that is we think about balancing and we think about elimination. Okay, we've got two sets of equations here. X plus y equals 5, x minus y equals negative 7. I'm going to call the first one equation 1. I'm going to call the second one equation 2. What we can see here is that we've got one lot of x's, one lot of y's, and some numbers here. Okay, we're all in the same order. It's x and y, x and y. Okay, if it wasn't in this order, if there was a y over here, we would need to rearrange it so that these were both in the same order. Okay, so what we're going to do here is we are going to try and cancel down the y's. Okay, just cancel down the y's in this question here, because if we look here, we can see that we have got a plus y and a minus y. So we can maybe do something here to get these to cancel down. What we can do is if we add equation 1 and equation 2 together, what we're going to have is we're going to add together the two left hand sides and we're going to add together the two right hand sides. If we add together the two left hand sides, we're going to have x plus y plus x minus y. So that is going to give me 2x, and these two y's will cancel down. These will disappear. So 2x, and then adding together the values on the right, 5 plus minus 7 is minus 2. Now I'm just going to solve this equation as I normally would. I would divide both sides by 2, and I would have x equals minus 1. So I now have the x coordinate of this equation. I just now need to find the corresponding y coordinate. What I'm going to do is I'm going to substitute x equals minus 1 back into equation 1. So what I'm going to do is I'm going to sub x equals minus 1 into 1. So x plus y equals 5. I've said that x is minus 1, so minus 1 plus y equals 5. I want to find out what y is, so I want to have y on its own on the left hand side. So I want to get rid of this minus 1. The opposite of subtracting 1 is adding 1 to both sides. And that is going to give me y equals 6. Okay, so the solution to this pair of equations is x equals minus 1, y equals 6. And if we compare that, these are the exact same equations that I used when we were doing the graph method, and we spotted that when we did it graphically, we got the coordinates as minus 1, 6, and we get the exact same coordinates when we do it algebraically. So what we've done here is we have labelled our first equation, labelled our second equation, and because we've got a plus and a minus here, we've tried to eliminate this variable. We've tried to eliminate the y's. So we've added 1 and 2 together. Okay, so if we add these two together, we're going to get 2x. These will disappear, and that will give me minus 2. And then I would solve to find out the value of x. I then substitute that value of x into my first equation. I then solve, and I state my solution. A further way to check if you've got your answer correct is if you substitute your values back into the second equation as well. So we got the values minus 1 and 6. So if we substitute these values into this equation, it should work out. So if this was minus 1, we're subtracting 6, we should get minus 7, which we do. So we know we've got this correct. In simultaneous equations, you will always know if you've got the answer correct. Okay, here I'm just going to go through a similar example. X plus y equals 9, x minus y equals 7, and I want to solve this pair of algebraic equations simultaneously. I'm going to call this number 1, call this equation 2. And if we have a look again, we should be able to identify that if we added these two values together, these would cancel down, these would disappear. So what I'm going to do is I'm going to add equation 1 to equation 2. By doing so, that will give me 2x. The y's will cancel because we want to eliminate a variable here. So I've chosen to eliminate the y's here. So 2x equal to 16, and if I was to solve that, I would get x equal to 8. I'm going to then substitute sub x equals 8 into equation 1, which was x plus y equals 9. So I'm going to have 8 plus y equals 9. And if I were to solve that, I would subtract 8 from both sides, and I would have the value of y equal to 1. So my solution is x equals 8 and y equals 1. I've solved these equations algebraically. I can check if I've got that correct if I substitute these values into equation 2 as well. X minus y equals 7. So if I did 8 minus 1, that does equal 7. I know I've got it correct.